Your oscilloscope can be used to make a phase measurement. Here, for instance, I have the output of a high-pass filter on channel 2 on the oscilloscope. And I'd like to know what its phase is, or the phase shift of the low-pass filter. Obviously, though, to make a phase measurement, you have to make a phase measurement relative to something. And so we have to put in the driving signal, the input signal to the high-pass filter. And I can put that in right over here on channel 1 and display it. Now, once that's in, we can turn channel 1 on, and you can see we've got a nice picture of the input signal on channel 1, as well as the output of the signal generator on channel 2. By the way, this is following a convention that's very useful to follow, where you have your inputs on the left and your outputs on the right. If you follow this convention, you'll get confused much less often. What next? Well, the next thing to do is to turn on a measurement of the phase. So we can go to measure over here and then add a measurement, and the type of measurement we're going to want to make is a phase. So we can just add that measurement in, and we're measuring the phase. But it's kind of noisy, so how can we improve that? The first thing to do is to make sure that our output signal, the blue signal over here, is relatively large. At the moment, it's so small, the scope is having trouble latching onto it. So let's kick that up until we get a plausibly large signal. And now you can see that the phase measurement is settling down a little bit, but it's still noisy. And it's noisy because of all of the fuzz on your waveform. Best way to get rid of the fuzz is to use averaging. Now, of course, to do averaging, you first have got to get the trigger right. And I've already set up the oscilloscope for auxiliary triggering from the wave generator that's making the input signal, the signal here in yellow. So let's turn on averaging. And here we go. Averaging is on, 256 averages. Turn off the unnecessary menus, and you can see that the phase has calmed right down to a phase of minus 86.5 or so degrees. It's a nice steady measurement, and it's an accurate measurement. Very close to 90 degrees, in fact. As always, when you make any measurement on the scope, you want to confirm that the measurement makes sense, which you can do simply by looking at these two wave functions. If I look at the blue wave function, it's clearly got a peak right around the center point over here, and the input wave function, the yellow one, has a 0 at exactly that same midpoint on the scope. So we know that the proper measurement is going to be very close to 90 degrees, confirming the value that we measured over here of minus 86 degrees.